Welcome back to The Working Thesis, where we map out the strategy of the agent era. I am Maya, and today we are tackling perhaps the biggest, most seductive marketing claim in the entire AI industry. This agent grows with you. You hear it in almost every keynote. The pitch is that the AI supposedly learns your deeply idiosyncratic habits, memorizes your sprawling code base, anticipates your preferences, and over time, seamlessly becomes an intuitive extension of your own mind.
Right. It is an incredibly powerful pitch because it promises to solve the cold start problem. Nobody wants to explain their job from scratch every morning. But as of 2026 and still evolving, what does that actually mean under the hood? When you correct a coding mistake, is the AI actually learning the way a human learns by dynamically rewiring its digital neurons? Or is it just doing a really good job of taking notes for the next time it wakes up from its stateless slumber?
Today, we are mercilessly separating the myth of self-improvement from the highly practical reality. We are going to look at the massive structural difference between context layer memory and true weight level learning. We will explore the cloud agents that are currently quietly maintaining code bases in the background, and we will look at the local, private dream you can actually build for yourself today.
It is absolutely crucial to get this right because the word learning is doing an unbelievable amount of heavy lifting in product marketing. If you expect an agent to fundamentally change its raw reasoning capabilities just by talking to you, you will be deeply disappointed. But if you truly understand how to leverage its meticulous note-taking abilities, you can build something profoundly powerful. A quick, honest note before we start. This is a thinking out loud series about where AI agents are heading. It is exploration and opinion, not advice of any kind.
We will flag the difference between what is actually shipping today and where we think things are going. This is a 2026 snapshot, and it is evolving fast. So treat it as a map, not a forecast, and go explore for yourself. Let's start by rigorously defining what is actually happening when a product ships today and proudly claims to learn. Today's self-improvement is entirely happening at the context layer, not through weight learning. The underlying LLM, the incredibly expensive brain in the jar that costs billions to train, remains completely, permanently frozen. Its neural weights are not changing one bit when you talk to it.
Exactly. What is changing is the harness wrapped around that frozen brain. The harness is tirelessly building memory notes, compiling skill libraries, and editing instruction files. Every single time you correct the agent, it writes a little digital sticky note and saves it to a hidden file. The next time you start a session, the harness grabs all those accumulated sticky notes and silently injects them into the massive system prompt before the brain even wakes up.
Think of the analogy of a new executive assistant. You could theoretically have an assistant who literally, biologically alters the physical structure of their brain overnight to permanently engrave how you like your coffee. Or you could have an assistant whose brain stays exactly the same, but who keeps a superb, meticulously indexed notebook that they intensely study for 10 seconds every morning before you walk in.
Today, we overwhelmingly have the notebook. And to be crystal clear, a superb notebook is incredibly effective. When the agent automatically applies your team's hyper-specific, somewhat illogical naming conventions because it read the note it took yesterday, it absolutely feels like true learning. But strategically and technically, it is highly structured note-taking. The model isn't rewiring itself, it's just being aggressively reminded of the rules every single time it blinks.
So how are the major platforms successfully using this context layer memory in practice? We are seeing a massive, coordinated push toward what I call cloud background maintainers. These are agents that don't just sit idly waiting for you to chat with them. They live natively in your repository and actively try to improve it while you sleep.
We have several absolute heavy hitters in this space right now. You have Claude Code Routines, OpenAI's Codex Cloud, the GitHub Copilot coding agent running asynchronously in the background, and Google's Jules. They are all configured to wake up on a cron schedule or a push webhook, read the latest context, and hunt for code optimizations, stale dependency updates, or glaring test coverage gaps.
And because they heavily rely on that persistent context layer, they can pull down your codebase's internal style guide and ingest thousands of previous PR reviews to deeply ensure their work matches the team's historical, unspoken preferences. They generate the fix, test it rigorously against the automated oracle, and bundle it up into a perfectly clean package.
But, and this is a massive structural but that defines the current era, none of these enterprise tools are just pushing code straight to the main branch unattended. They all aggressively stop at the exact same critical boundary. They open a PR. They submit a pull request and sit there, patiently waiting for a human to review it.
Which brings us right back to the core theme of our entire series. Verification is the wall. Even with access to incredible, deeply personalized context, these cloud maintainers still firmly require a human in the merge loop. The agent can take great notes, but the enterprise still absolutely demands a human to verify the final, irreversible output.
Because ultimately, the cost of a hallucination in a live production environment is simply too high. The Copilot coding agent might be 95% accurate when it writes a background fix, but that 5% failure rate means you cannot legally or practically remove the human confirm gate. The human structurally transforms from being the primary author to becoming the editor-in-chief of the AI's work.
And honestly, that is the most correct and responsible posture for 2026. The companies that are actually succeeding with these background agents aren't foolishly trying to achieve zero human involvement. They are trying to reduce the human's job from painstakingly writing the code to simply reading the code, running a quick mental test suite, and clicking approve. It is a massive productivity gain, even with the human standing at the gate.
It changes the developer's job from a typist to a high-level reviewer. But what if you don't want your proprietary code and your personal quirks sitting in a massive cloud provider's repository? What if you genuinely want an agent that grows with you, but you demand to keep all those intimate contextual notes entirely private?
That leads us to the clearest local embodiment of the agent that grows with you dream. If you want maximum privacy and extreme, untethered personalization, the state-of-the-art right now is Hermes. Hermes represents the polar opposite of the massive, cloud-hosted enterprise maintainer.
Hermes runs entirely locally. It relies on self-authored skills, a heavily tuned dedicated user model, and proactive memory, all living exclusively on your own hardware. When Hermes learns a new trick or a new workaround for a bug, it literally writes a new Python tool for itself and saves it locally. It builds an incredibly dense profile of who you are and exactly how you work. And it never, ever sends that profile to a central server.
Here's me thinking out loud. Let's extrapolate this local, highly personalized notebook to its logical endpoint. This next part is speculation, but picture a Tuesday morning in 2029. You are a senior developer who has been using a local Hermes agent for 5 straight years. It has watched you meticulously debug React components 10,000 times. It hasn't just taken notes. It has written dozens of permanent MCP testing tools specifically customized for your personal, idiosyncratic coding quirks.
I love this. It's essentially becoming a digital twin of your specific engineering brain. And because it runs locally on your own hardware, if you decide to quit your job at Microsoft and move to a startup, you literally just unplug the hard drive, put it in your backpack, and take your 5-year-old digital brain clone with you. You own the context. You own the deeply personalized harness. It is a completely portable, compounding intellectual asset.
Exactly. The dream that you can build for yourself today, completely privately, is a local instance of Hermes hooked up to a strong local model, triggered by a local cron routine. The big cloud providers are renting you a brilliant intern who forgets you exist the moment you close the tab. Hermes is trying to build the permanent, private, portable notebook. But what about the other side of the coin? Is anyone actually working on true weight-level learning, where the model itself genuinely gets smarter through trial and error without relying on sticky notes? The answer is yes, but it is strictly sandboxed research, not a shipping product.
Exactly. If we look at the research labs, we see some genuinely mind-bending experiments. Take Sakana's Darwin-Gödel machine. They demonstrated a system that essentially mathematically evolves its own logic, showing highly illustrative leaps, reportedly moving from solving around 20% to 50% of the SWE-bench benchmark purely through autonomous self-improvement loops.
And over at MIT, you have the SEAL framework, which is actually pushing real, permanent weight updates based on the agent's interactions with its environment. These systems don't just take notes in a text file, They actually biologically, well, digitally, alter the underlying neural pathways of the LLM to cement the new knowledge permanently into the brain.
It is the ultimate holy grail of computer science. If an agent can improve its own weights autonomously by looping relentlessly against an oracle, you have the exact recipe for an intelligence explosion. But right now, today, these are lab experiments for a very good reason. They are dealing with massive, unsolved structural problems that forcefully keep them out of commercial products.
The two biggest, most stubborn unsolved problems with weight-level learning are catastrophic forgetting and safety. Catastrophic forgetting is exactly what it sounds like. When you forcefully mathematically update a neural network to learn a new specific trick by shifting its weights, it often accidentally overwrites something fundamental and crucial it already knew.
Think of it like this. It is like trying to learn how to expertly play the piano, and in the process of rewiring your brain, you accidentally completely forget how to speak French. The weights in a massive LLM are so densely, incomprehensibly entangled that you can't just easily surgically update one tiny fact without destabilizing the rest of the model's core reasoning capabilities.
And the second massive problem is safety. If a model is updating its own weights in the wild, unsupervised, how do you mathematically ensure it doesn't learn malicious or deceptive behavior? How do you ensure its alignment doesn't slowly drift over a million iterations? With context layer memory, if the agent acts weird, you can just open the text file and delete the bad sticky note. With weight-level learning, the bad behavior is permanently baked into the brain.
That is exactly why you don't see true weight learning in Copilot or Claude Code today. The industry has collectively realized that, for now, the context layer approach, taking really good, easily editable notes, is dramatically safer, highly predictable, and exponentially easier to debug than trying to let the model blindly rewire itself on the fly.
Let's rigorously recap. When a company claims their agent learns you, they almost exclusively mean context layer memory. The AI is taking great notes and re-injecting them into the system prompt, not fundamentally changing its neural weights.
We see this deployed heavily in cloud maintainers like Claude Code Routines, Codex Cloud, Google Jules, and the Copilot coding agent, which can work tirelessly in the background, but always keep a human in the merge loop. For a fully private, highly personalized local version of this, Hermes is the clearest embodiment of the dream today.
True weight-level learning, like Sakana's Darwin-Gödel machine or MIT's SEAL, is showing incredible promise in the lab, but remains heavily constrained by catastrophic forgetting and unproven safety risks. For now, it's learning me means it's taking great notes. And honestly, that is powerful enough to change the world.
But self-improving code is just one of the wild things happening at the bleeding edge of the industry. What else is brewing in the deep labs? What happens when you put 100 agents in a simulated town or give an agent control of a physical, hydraulic robot?
That is exactly what we are covering next. Next time, we are doing a rapid-fire lightning round. We are opening the cabinet of curiosities to explore the new frontiers. See you then.
And that is us thinking out loud for today. If this gave you a clearer map of where the agent era is heading, do us a favor and subscribe. It genuinely helps more curious people find the show.
We are figuring this out right alongside you, one episode at a time. So hit follow, and we will see you in the next one.